Welcome to Trend Analysis and Error Corrections. So far in this module, we've learned 3 different mathematical models that we use for forecasting future demand. In this video, we're going to apply that math against historical sales data to see how this works in our forecasting efforts. First, we will make any necessary adjustments to remove inaccurate historical sales data caused by events. Those are the spikes and dips I've talked about before, because they don't properly reflect what our sales history would have been absent that event or the events. Next, we will apply our 3 different mathematical models to forecast future demand based on our newly cleaned historical sales data. From there, we will analyze the effect of lagging and bias in our forecasting methods and make corrections that will give us a forecast that we can have confidence in. So we have lots to cover in this video, and to do that, we're going to do some work on an Excel spreadsheet. And welcome to Excel. All right, what I've done here is I've captured 12 months of sales data from a product. I've laid it out 3 different times, and we're going to apply our 3 different models to the same data to see what differences there are in the different methods that we can use. The first thing we're going to do, though, is we're going to address April. As you can see, in March had 333 units sold, May had 322 units sold, and April was down by 100 units. Something happened in April. Let's say we ran out of inventory. This could be a new product where we just did a test order and it did better than we thought. We ran out of inventory, so we brought some more in, and then we started to load up. Whatever the scenario is, doesn't matter, but let's just say this event was running out of inventory. So we don't want to run our numbers with bad data. And when I say bad data, this is an event, an historical event that occurred, but what we want to do is we want to assume that we didn't have the event, and we want to figure out what our forecast would be without that event. That'll give us better numbers. So what I do to smooth out the effects of an event, whether it's a dip or a spike, is I average the 2 months that precede it and follow it. So I will take 333 and 322, average them to get what I would have had without the event. So how I do that on Excel is really simple. I click the cell that I want to adjust. I come to auto sum, and for those of you familiar with Excel, this is just really basic. For those of you that are not, don't get lost, it's not a big deal. But I take this value in this cell, I add it to this value, and I come up here and I say multiply by 0.5, because we're only taking 2. So we can multiply it by 0.5 and get the average. So let's multiply it by 0.5. Now that gives us 328. So that makes sense. 333, 328, 322. This is a good average between these 2 values. All right. So what we've done is we've cleaned up the data. Now I will say that all the way back in April is really not going to affect what we're solving for here, but it does make a difference. And if this is a significant event, then it will skew our numbers going forward. If the event happens here, it certainly will affect our forecast the closer it is to the month we're trying to solve for. So we're solving this event that actually occurred in this data, and now that we've done that, we'll apply our math. I hope that makes sense. We want to clean up our data before we apply our math. Otherwise, we're going to bake some bad numbers into the cake of our forecast, and we don't want to do that. So now that we've corrected for our event, let's look at the different moving averages that we have. We've got our simple moving average here. We've got our weighted moving average here. And we have our exponential smoothing here. Now what I've done is I've put the formulas in for each one to save us some time. And these are our formulas. You've seen them before in the prior videos. And what I've done here is I've taken all 3 for the simple moving average. I've taken these and averaged them here. And then we're going to move forward, and we're going to take this value. In fact, we'll just do it now. We're going to copy it, and we're going to paste it moving forward through the balance of our sales history. Then we're going to go down here. This is our weighted moving average, where I've used a 0.2, a 0.3, and a 0.5. And we're going to advance that formula forward on the sales data here. And then for the exponential smoothing, I have a 0.7. So we're going to apply a 0.7. And we're going to move that forward here. Now let's see what the results are. This is an example of our lagging and our bias. Now, I've explained lagging before, and that is, it's the effort of the forecasting method to keep up with demand one way or the other. Lagging is just a simple part of forecasting. Bias as well. The bias is how the different methods work against the same data. There's going to be different values assigned, and that's just the bias that's factored in to the mathematical model used against the data. Not a big deal. But let's talk about the trend errors here. And for that, I'm going to go back to a quick PowerPoint to show you how we calculate all this information so you can understand what it means. So how do we deal with errors? Well, to deal with errors, believe it or not, we have an error correction formula. But don't let this bog you down. There's math going on here. But remember, I just want you to understand it conceptually, almost intuitively. I'm not going to bog you down with knowing how to do the math. I just want to teach it to you so that you understand what's happening, and all the while knowing that our program is doing all the heavy lifting for you. You just need to know what it's doing and why. So there is an error correction formula, and it looks like this. Forecasted sales minus actual sales divided by actual sales. What does that even mean? Well, let's take a look. Let's look at the top one. Let's look at the trend error we have for the simple moving average. Our demand totaled, those 12 months totaled to 6,608 units. Our forecast came up with 5,484. We were lagging on all of them, and we have bias on all of them. So the combined lagging and bias on the simple moving average had us down 1,124 units, which was 17%. So how do we get to the 17%? Well, the way we did it was we took our forecasted sales, subtracted our actual sales, and then divided by the actual sales. Let's see what that looks like. 5,484 subtracted 6,608 divided by 6,608 gave us 1,124 divided by 6,608, which is negative 17%. That's how we got a trend error of 17%. The weighted moving average had a 15%. The exponential smoothing had a negative 12%. So what do we do about that? I remember at one point I said, don't worry about it. We'll take care of that later. Just understand the numbers. And that was fine for them because conceptually I just wanted you to understand how the math worked on the different moving averages and the exponential smoothing. But now we have to do something with this. As I've said on handling the events, we have to clean up our data. Well, we also have to kind of clean up our forecasting method as well, because we can't bake this into the cake of forecasting our future sales. So how do we handle this? Well, the way we do it, of course, is through a little bit of extra math. Let's look at this 17%. We're down 17%. So what do you think would happen if we just multiplied everything by 1.17, multiplied it by 17%? Well, let's find out. I've already done that in our Excel spreadsheet. So let me tell you what happened. I took this value that averaged these three first. We already cleaned our data, so we've got working on good data. Now, I've taken this value, the average, and multiplied it by an additional 17%, 1.17. And then I extrapolated that all the way through. And now our trend error is down to negative 3%, which is good. But we're still 200 units short. Now, 200 units out of 6,600, that's really close. I mean, goodness, that's close. But we can do better. So how do we do better? Well, the short answer is, in the Inventory Boss, we use AI in two different areas. One is dealing with errors, error correction, and the other is in refinement. Refinement's the 8th step. We're a ways from refinement. But right now we're dealing with errors, and I will tell you that the Inventory Boss is just going to do it for you. You got to click a button, and it'll tell you exactly what this value here should be to bring the trend error down as close to 0 as possible. Once you have that, wow, now you've got some great confidence in going forward with your forecasting. Now, one more thing. In the forecast that we were correcting, we had forecasted too few units. But what if you over-forecast? Well, if you had overestimated demand and had too much inventory, we would be multiplying by a value less than 1. So we tried to make up for a shortfall by multiplying by 17% in a positive way. We were down 17%, so we tried to multiply it by 17% to bring it close to zero. If we had overestimated and we needed to downgrade that estimate through our error correction, we would have to multiply by a value less than 1. Now, one more thing before we wrap up, and that is you can correct some errors initially through the actual calculations. If we look at the exponential smoothing, I sometimes call it the smooth moving average, but it's really exponential smoothing. I had a multiplier of 0.7. Let's say I moved that to 0.8. What would that do? Well, as you can see, it bumped it down to a negative 0.11. One more time. If I have it at 7, I'm down 812 units. If I make it 0.8, down 716. If I make this a 0.9, which is the highest you'd want to go, the absolute highest you'd want to go, you got it down to a 0.10. So it could be that this is your go-to. It could be that the exponential smoothing is your go-to method. It's completely up to you. I typically use the weighted moving average, but there are some products I use exponential smoothing. They just work on different products better. The nice thing is, whichever one you choose, since you're correcting your errors, you're going to get really close between your forecast and your demand. It just works out that way. But I just want to make sure that you realize that there's another way to correct the errors, and that is to modify the variables in either the weighted moving average or exponential smoothing. So let's have a quick recap of what we learned so far. First thing we do is we clean our data. We clean our data to make sure that we're not baking any bad numbers into the cake of our forecast. After that, we select the forecasting model, the trend analysis model that fits best for our products, brings us the initial lowest trend error, and then after we've got that part figured out, we do some error correcting and we correct the errors. Now again, in the inventory boss, all you're going to do is click a button and it corrects it for you, and then you move forward to the next step. Now the next step is going to be factoring in seasonality, and then figuring out your forecast horizon, and then extrapolating your data forward, making any manual adjustments for known events like Prime Days or Black Friday or a coupon promotion you're going to do. And then once you've done that, press a button and you've got yourself a forecast of the future sales your business will very likely have for the forecast horizon that you've selected. And those are the steps we have ahead of us. So let's move on now to the next module, which is seasonality. I'll see you in that video. Thanks for watching. Inventory Boss helps e-commerce sellers increase profitability by balancing their business through solid inventory management best practices. Visit inventoryboss.com today and get all of our training and the use of our cloud-based software for an initial price of only $10 for the first 30 days. Get started today.